Welcome to section 5.1, and here we get into polynomials and what are polynomials, what are not, so on and so forth. Now, basically, a polynomial is a function or a polynomial in X. Simply means that when it's all said and done, the variable X always has positive integral exponents, and that can include 0. It can be 0 also, but it can be 0, x to the first, x to the second, x to the third, but it cannot be x to the 1/2 or x to the -2 or anything like that. So it needs to be 0 or positive, the x exponent does, and it has to be an integer. And so with that in mind, realize that we have several different ways that we can try and attack these particular problems where we are asked, is this a polynomial function, or if it isn't. And if it is, then we need to give its degree. And if it isn't, we need to tell why it isn't. So number one, I see that the 6 is in the denominator, so that means I can give that 6 to both or all terms in the numerator. So 6 over 6 minus x cubed over 6 can be written as 1 minus 1/6 x cubed. And basically, since the only exponent to x is a positive 3, it is sufficient. So yes, this is a polynomial function, and its degree, the degree is always the biggest exponent that there is, and so here it would be 3. Number two, it's not really necessary, but this isn't too difficult to actually distribute that x, and so we get x squared minus 15x. Now realize, when there's no radicals involved or no fractions, and pretty much we don't have to worry about it. It's just a matter of what is the degree, because we look here, positive exponent, positive integral, and a positive integer. And so yes, this would be a function of this would be a polynomial function as well, and the degree here would be 2, because that is the biggest exponent that we have. Now number 3, I am no way, shape, or form am I going to multiply x minus 1, that quantity raised to the 11th power. But I am going to say, okay, I know that very first term is going to be 6, and then this will be x to the 11th power, and then we'll have the 10th power, 9th, 8th, all the way down to the constant. And likewise, x plus 1, the quantity raised to the 5th power, is x to the 5th power. And so what I'm doing here is I'm just looking at the first term of this whole thing, and this would equal 6x to the 16th power, and then we'd have 15th, 14th, all the way down to the constant. But nowhere are there fractions or radicals. So yes, each and every one of these would have an exponent that is either positive or 0, and they would all be integrals. And the degree happens to be this very first one, the biggest one, which is 16. Now 4 through 7 basically asks us to transform the graphs, and much like we learned families, we're going to learn families here. X to the 4th will be the values 0, 0, 1, 1, negative 1, 1, 2, 16. And realize most of the time that will actually take you out of the graph, and negative 2, 16. So those are just the graphs of x to the 4th, the 4th power. X to the 5th, the general points are 0, 0, 1, 1, negative 1, negative 1, 2, 32, so this even takes us out even further, and negative 2, negative 32, so we're way down here. And so realize x to the 4th is just a very sharp parabola, and x to the 5th takes on the same general shape as x cubed. It's just a whole lot skinnier. in general. And so we are asked to use transformations to graph all of the following. Let's look at number 4. Number 4, we are asked to find f of x equals negative 1/2 x to the 4th. So we know it's going to have the family of x to the 4th, but more specifically we're going to reflect over the x-axis, and we're going to compress by 1/2. So I start out, normally I'd have 0, 0, reflect it, it's 0, 0, and compressed by 1/2, it's 0, 0. So our new axis is going to be here. The only thing is everything's going to be reflected over the x-axis. So we start out 1, 1, reflect it, and then compress it by 1/2. So that becomes 1, negative 1/2. Negative 1 becomes negative 1/2. Now here where we might actually see some difference. 2/16 is the normal one. Well, we reflect it, so it becomes 2 negative 16, but we're going to compress it to 2 negative 8. And negative 2 would be up here at 16. Reflect it, becomes negative 16, and compress it, becomes negative 1/2. And so we just get the shortened version and inverted version as well. Let's go on down to the next page. Example 5, 6, and 7 are all pretty much the same, just a little more involved as we go through. Number 5, f of x equals negative 2 times the quantity x minus 4 raised to the 4th power plus 4. So I know I need to reflect over the x-axis. I know I need to stretch it, not compress it. Stretch by 2. I'm going to go 4 to the right. That's what that minus 4 still means. And the plus 4 means we're going to go 4 up. So, giving myself ample time. And I know the family is the 4th power. So 0, 0, reflect it, stays there. Stretch by 2, stays there. 4 to the right. And 4 up. And so there's my new vertex. And so what I'm going to do is I'm going to create a new set of axes. I realize I haven't done this a whole lot, but it really does make sense. I've got a whole set of axes, and let's look at what happens in general. The reflection over the x-axis, rather than going like this, is going to go more the inverted. Stretching by 2 means it's going to be even further stretched than what it was. The 4 right and the 4 up have already been taken care of because I have my new set of axes. So normally I'd have 1, 1, but it's on the bottom and it's stretched by 2, so it's actually going to become this point here. With respect to this set of axes, it's 1 to the right and 2 down. Likewise, 1 to the left and 2 down will be that one. Then it would be 2 and then down 32. And that's way out of range. So realize it becomes a very skinny parabola, relatively speaking at least, and it just goes down. That looks similar to that. Now 6 and 7 are to the 5th power, so we will use that parent function. Number 6, f of x equals negative 1/2 x to the 5th. So here it's reflect over the x-axis, and we need to compress by 1/2. So 0, 0, reflecting stays at 0, 0, compressing stays right at 0. Now 1 normally was 1. Reflect over the x-axis becomes negative 1, but compress it by 1/2, so it becomes negative 1/2. 2 was 32. Reflect over the x-axis is negative 32. Compressed by 1/2 makes it negative 16. So that's going to still be quite a ways down here. Now likewise, negative 1 is normally negative 1, but reflecting goes to positive 1. Compress is 1/2. Negative 2 is normally negative 32. Reflect over the x-axis becomes positive 32, and compressed by 1/2, and it becomes 16. And so we get this general shape that looks like this, and we will continue on the next video.